Hey, this is Ken Rosever, and I thought I'd do our startup a little different. Instead of giving it to you at the beginning of class and then talking about it in class, because we have a lot of material to cover, I decided to record the solution to the startup and put it up on YouTube. So I hope this video comes out well. There's two problems in the startup. I said to try the first one today. It said, find the domain of the following functions and express answers in interval notation. And on your sheet, I also showed the steps to going through this. So we had steps where set denominator equals 0, solve by factoring. Solutions are values that make the function undefined. So solutions are restricted from inclusion in the domain. We're going to write our answer in set builder notation and interval notation. The reason I just said interval notation up here is because that is what you will be responsible for on the test. But it's good to know both. So let me go through those steps. The first step is you want to set the denominator equal to 0. Because what makes the function undefined is any value that makes the denominator equal 0. So I'm going to go and take the bottom, 3x squared minus 4x equals 0. And I'm going to factor it. I can factor x out of both of those. And then I'm going to solve this. So by zero product property, if this times this equals 0, then either x has to equal 0, that's the first factor, or the second factor, 3x minus 4, has to equal 0. So we already have one of our solutions to this equation. And the other one, if we move the negative 4 to the other side, it becomes positive. And if we divide both sides by 3, we get 4/3. So the solutions to this equation are 0 and 4/3. Well, those solutions are what make this equal 0. And if those values make this equal 0, then they make this denominator equal 0. And therefore, they are not allowed to be part of this function's domain. So the domain of this is x's such that x does not equal 0 or 4/3. That is the set builder way of notating that answer. However, I wanted it in interval notation, so we would say x can be anything on the whole number line except for 0, and also except for 4/3. So it can be anything to the left of 0, it can be anything between 0 and 4/3, it can be anything to the right of 4/3. So that goes to negative infinity, that goes to infinity, and so what we see is we have 1, 2, 3 intervals. So we'll have 2 unions, and our answer will be negative infinity to 0. That's our first interval. We can't include 0. Union, 0 to 4/3, that's between. Union, 4/3 to positive infinity. None of these values are included in the domain. None of these boundary values. All right, let's go down here to the second one. And I'm going to zoom in on this a little bit. Let's see. So we're trying to find what values make this equal 0. If you want to try it on your own, if you haven't yet, I'd encourage you to pause the video and do so. But if you have, here I go. So we don't care what makes the top equal 0. All we care is what makes the bottom equal 0. So I'm going to go to 2x squared plus x minus 6 equals 0. When, let's see, does this factor, are there 2 factors? A times c is negative 12. Are there 2 factors of negative 12 that add to 1? Yes, there are. 4 and negative 3. Their product is negative 12. Their sum is positive 1. So this will factor, and if I'm using the AC method, I'll write 4x minus 3x. I'll rewrite the middle term as these 2 numbers. And then I'll do it by grouping. I can factor 2x out of both of those, leaving me with x plus 2 a negative 3 out of both of those, leaving me also with x plus 2. What matches is x plus 2. And when we do factoring by grouping, our result is always what matches times what's left, that being 2x minus 3. So that is the factorization of this. Once I have the factors, I use zero product property, which I like to call ZPP. I set each factor equal to 0 to find the solutions to this equation. So I will get 2x equals 3, x equals 3/2, x equals negative 2. So my solutions to this are negative 2 and 3/2. They are what makes this quadratic equal 0. Therefore, they are what makes this function undefined. And those are the values that must be restricted. So x can be anything except it can't be negative 2 or 3/2. On a number line, that would look like this. We'd have a hole at negative 2. We'd have a hole at 3/2. But anything in between those values or beyond those values is acceptable. And therefore, the interval notation would be negative infinity to negative 2, bracket or parenthesis, negative 2 to 3/2, parenthesis, 3/2 to infinity. So there's your startup for today. I hope you watched that video and that was helpful to you. I will also make a video for the other two problems that are on your sheet. So look for that later. Bye.